Hello students! So this is part 2 of solving quadratic equations using square roots. In that last video we looked at radicals or square roots in general, and first we talked about some definitions and some terminology involving radicals. Then we kind of discussed some of the things that you should expect when you're finding square roots of numbers. Next, we looked at simplifying radicals or writing radicals in their simplest form. And then from there, we introduced imaginary numbers, which are directly related to radicals. And we talked about exactly what imaginary numbers are and when it is that we should expect to see imaginary numbers. So in this video here, we're going to continue with solving quadratic equations using square roots, and we're going to go through enough examples of actually solving these quadratic equations. So let's say that we were looking at a few simple examples like this here, where we're asked to solve and write the answer or answers in simplest radical form. Regardless of I guess how the equation looks, when you're asked to solve the equation by using square roots, or when you can solve an equation using square roots, what you should do is you should make sure that the part that's being squared is isolated on one side of the equation. So in other words, make sure that whatever that part is that is being squared is by itself on one side of the equation. When we look at example A, or at part A here, where we see x squared equals 16, you can clearly see which part or what part of that is being squared, right? There should be not one question in your mind about the fact that x is being squared. X is the part that's being squared. So that thing or that part that is being squared is isolated, and it is completely by itself. You don't see anything in front here. You don't see anything behind it. You don't see anything up under it. It's completely isolated on one side of the equation by itself. So again, before you start trying to take any square roots, you have to make sure that part that's being squared is completely by itself. And in part A here, it is. So after that, what you should do is you should actually take the square root. So once you have the part that is being squared by itself, isolated on one side of the equation, then is when you can take the square root on both sides, or find the square root on both sides and solve. Alright, so let's do this. Let's take the square root on both sides. Alright, so we take the square root on the left side of this thing that's being squared, of x squared. So we're taking the square root of that, and we're taking the square root of 16. Alright, so here's something that's pretty important to know. When you are taking the square root of something that is being squared, so if you are taking the square root of something that is being squared, and here we can see that that's what we're doing. We're taking the square root of x squared in this particular case. So whenever you're taking the square root of something that is being squared, that square root acts as an inverse operation. So again, in this particular case, because we're taking the square root of something that's being squared, this square root is going to act as an inverse operation, and it is going to cancel out the square. So the square root is going to cancel out with the square. It's going to act as an inverse operation. Okay? Square root canceled with the square. Alright, so after that, so they've canceled out. Now we've got left x, and on the right side of the equal sign we still got this square root of 16. So in the last video, we made mention of the fact that when you are taking the square root of a number, there are usually two results, or there are usually two answers that we get. There are two versions of that answer at least. One version is positive, the other version is negative. So I think most of us either know that the square root of 16 is 4, or if you don't know, you can figure it out. Again, everybody has a calculator. If you don't have a calculator, you got your phone, and your phone will turn into, most smartphones will turn into a scientific calculator if you turn it sideways, where you should be able to take the square root of 16. Anyway, square root of 16 is 4, but again, we've got two versions of that answer because we're taking the square root of a number. So remember that we will write out this answer as plus or minus, and we'll use that plus or minus sign. And again, like we said in part 1 of this video, this plus or minus symbol here, it indicates that there are two versions of this answer. One version is positive square root of 16, and the second version is negative square root of 16. That's two separate answers. Okay, so again, this is two answers, one positive, one negative. Don't get it confused just because it looks like one answer. It is two different answers. Okay, so let's look at part B here. So again, with this one, we want to make sure that we get the part that's being squared by itself, isolated on one side of the equation. And again, we can see here that for this one, the part that's being squared is x. Okay, so we've got 16 plus x squared. We can see what's being squared equals 0. If we want to get that x squared by itself, we need to move the 16 to the right side of the equation. So we subtract 16 on both sides, which cancels that out, and we're left with x squared. Ooh, what is that? We're left with x squared equals negative 16. Alright, so then here, now that we've got the part that's being squared by itself, we're ready to take the square root on both sides of the equal sign. And so remember that when we are taking the square root of something that is being squared, like what we're doing here, that square root cancels out. It acts like an inverse operation, and it cancels out that squaring. So we're taking the square root on both sides of the equal sign, because you can't just take the square root of one side. That's not going to balance your equation. Alright, so again, on the left side, after that canceling happens, you're left with just x. And on the right side of the equal sign, we've got still the square root of negative 16, but again, remember that when we're taking the square root, even when we've got the square root of a negative number, it's still gonna be two versions of our answer, a positive one and a negative one. Also, guys, remember, we talked about what happens when you take the square root of a negative number, and we said that the only time that you've got imaginary numbers is if you are taking the square root of a negative number. In other words, if the radicand is negative, that number that's up under the radical, if it is negative, and you're taking the square root of a negative number, that means that you're going to have an imaginary solution. So, again, we've got the square root of a negative number, and we know that because we're taking the square root of a negative number, that this should be an imaginary number. Remember that during part 1 of this video, we talked about the basic imaginary unit, and and how the square root of the square root of -1 is that basic imaginary unit. So we're breaking down the square root of -16 into two different radicals. The square root of -1 times the square root of 16. Again, we said that the square root of -1 is that basic imaginary unit I. And we said whenever you've got an imaginary number, it is going to be written with that basic imaginary unit, with I. Okay, so again, the square root of -1 is the same thing as I. And so we replaced the square root of -1 with I. And so now we've got I times the square root of 16. So the square root of 16, again, the square root of 16 is 4. And actually, I meant to write that on this side as well, because again, the square root of 16 is 4. So that's technically plus or minus 4. Two answers. But this one is plus or minus 4i. Alright, so again, remember that plus or minus symbol, that there are going to be two versions of our answer when we're taking the square root like this. Usually there are two versions of it, a positive and a negative, and we use that plus or minus symbol there. So again, for part A, the two answers are positive 4 and negative 4. And so these are the answers for part A and part B here for example 1. And these answers are already in simplest radical form, because again, since we were able to take the square root of 16 and write it as 4, technically that is the simplest radical form here. Okay, so let's look at this second example here. Solve and write the answers in its simplest radical form. So for this one, if we are looking to solve this, remember the first thing is making sure that the part that's being squared is isolated or by itself on one side of the equation. And in this particular case, that part that's being squared is already by itself. The part that's being squared is the quantity of x plus 3 squared. And again, you can see in this particular case, that is what's inside this parentheses. Again, it may not, your equation may not have parentheses at all, but again, you should be able to identify exactly which part is being squared with or without parentheses. It happens to be easier with parentheses, but still. Alright, so we see which part's being squared. It's already by itself. So from here, what we need to do is take the square root on both sides. And remember that when we take the square root, you will see that square root acting as an inverse operation, and it will cancel out the squaring. Okay, so again, when we take the square root on both sides, we see that cancels out square root and a square. What we're left with is x plus 3 equals square root of 14. However, remember, guys, again, that when we're taking the square root like this, we've got two different versions of this answer, because both versions can make the equation true. One version's positive, the other one's negative. Okay, so right now we have x plus 3 equals plus or minus the square root of 14, And what we still have on the left side of the equal sign is x plus 3. Now, again, folks, so what we did so far was we took the square root on both sides. That canceled out your squares. And again, just like in the examples up above, when we took that square root, immediately there was a plus or minus that happened when we take the square root on both sides of the equal sign. That leaves a plus or minus for this number here. And so there's one thing that we still need to do in order to solve this equation. And most of us, I'm pretty sure, can tell that because we got x plus 3 here, that what we need to do is subtract 3 on both sides of the equal sign. Because what we have is x plus 3 equals some number. Even if you don't realize that this positive 14 and negative square root of 14, positive square root of 14, again, it's a real number. It's just a number. Okay, it may look different than what you're used to, but it's just two numbers, two versions of the same answer, but it is just a number. All right, so we do that. That cancels out the 3's on both sides, and we are left with x equals. So when we write out this answer, please do not try and put together the 14 with the 3. Please do not try to do that. Okay, this 14 is not a 14. That is the square root of 14. And there are two versions of that square root of 14. One positive and one negative. So again, please do not try to put together the 3 and the 14. Do not try to say 17. Do not try to say 11. Okay? Because that is not going to work. No. Alright, so when we do write this out, if we're going to write it in its simplest radical form, there's no way to simplify the square root of 14. However, if we're going to write this whole expression here, the negative 3 and the plus or minus the square root of 14 in its simplest radical form, there are two ways that we can write it. We can either write the negative 3 first. So it can be written like this: negative 3 plus or minus the square root of 14. Literally two versions of it. One version is where it would be plus the square root of 14, and the other version would be minus the square root of 14, right? And so that's one way that we could write it, with the plus or minus symbol. The other way that we could write this is we can write the plus or minus square root of 14 first. So we could write it like this, and then we could put the minus 3 last. But again, we do not want to try to combine these. Again, I don't want to talk about too much in this video, but this is the square root of 14, and I'm going to erase what I'm writing right now after I write it. But this is the square root of 14, and the number in front of that is 1. Right now, the coefficient there technically is 1. It's 1 times the square root of 14. In order for us to be able to combine something, actually combine something with that, it would have to have the exact same radical. Like, it would have to be something like this: 3 times the square root of 14. So 1 times the square root of 14 plus 3 times the square root of 14. That can be combined sort of the same way that like terms can be combined, where that would be combined and written as 4 times the square root of 14. And again, I'm going to erase this. But again, so what we have right now is not something that we can put together and combine. We can't say 17, or we can't say 11, or the square root of 11, or anything like that, because it's not written like what we see over here. where both things have the square root of 14, because they don't have the same radical, so you can't put them together, combine them like we would like terms. All right, so again, I'm going to erase this. Okay, so again, these are two different ways that you can write out the answer here for example 2. Just remember that again, it was not possible to simplify that square root of 14. So again, it was not possible to simplify that radical, but again, we had to write our terms separately because they were not both whole numbers, and they were not both radicals with the same radicand. So again, one of them was a radical that had 14 as a radicand, and the other one was a whole number. So again, that's example 2. Okay, so let's look at this example 3. So remember again, the first step is getting the part that's being squared all the way by itself, isolated on one side of the equal sign. Remember that right now, the way that this is written, please, I hope that you don't get confused by this. When you look at which part is being squared, this -3 is not being squared. The -3 is being multiplied times the part that's being squared. The part that's being squared is still just x. It's only x that's being squared. Remember, -3 is a coefficient in front of the x, which means that technically that coefficient, -3, is being multiplied times that. So this is multiplied times -3, but again, the part that's being squared is x. Okay, and then we have a part here that's being subtracted. So again, that part that's being squared needs to be isolated by itself, and if we're going to do that, we're going to have to add 8 to both sides of the equal sign. That's going to get that to cancel the 8s. We're still going to have -3 and x squared, and this is going to be equal to 24. And then from there, we've got to divide both sides by -3. Divide both sides of the equation by -3. Okay, so we do that. The -3's cancel out. We're left now with the part that's being squared, which is what we want. That part that's being squared, isolated completely by itself on one side of the equal sign. Alright, so now we've got here that x squared is equal to -8. Alright, and technically we don't need those parentheses anymore. X squared equals -8. Well, we didn't need the parentheses at all, but again, I just wrote the parentheses so that you could clearly see which part was being squared. Alright, so when we get to this part here, we want to again take the square root on both sides. Since we've got the part that's being squared by itself, now we can take the square root on both sides, and that square root is going to cancel out the square. Remember here that we are taking the square root of a negative number, and that is going to wind up being an imaginary answer. Okay, so we've got this part that's being squared by itself. Now let's take the square root on both sides. Square root of this, x squared, square root of x squared, and square root of -8. Again, remember that when we're taking the square root of this part that's being squared, it's going to cancel out the square. Alright, so on the left side we're going to be left with x. On the right side of the equal sign we're going to be left with plus or minus square root of -8. And remember, because we're taking the square root of a negative number, that this is going to be an imaginary solution. So again, remember we had said that the square root of negative 8 is the same thing as the square root of negative 1 times the square root of 8. And we had said that square root of negative 1 is the same thing as I, that basic imaginary unit. So we've got I, the square root of negative 1, that's I, times the square root of 8. So I times the square root of 8 will be how this is written. And we can actually simplify this further. The square root of 8 can be simplified, can be written in its simplest radical form. So remember, we said that when you're trying to write or trying to determine whether or not a radical can be written in a simplest radical form, you want to consider factors of that radicand. So again, here we want to consider factors of 8, and we want to consider which factors of 8 are perfect squares, and we want to choose the pair of factors that has the largest perfect square. Alright, so when we consider those factors of 8 and we look at the ones that have perfect squares, there's only one factor of 8 that's a perfect square. And so again, here it's pretty easy to choose that pair of factors that has the largest perfect square. So we're choosing the pair that has 2 and 4 in it. So we want to use that pair of factors to rewrite this radical as a product of two radicals, putting the perfect square first. So in other words, when we rewrite this, we're still going to have the plus or minus, and we're still going to have the I, because it's imaginary, but we're going to replace the square root of 8, and we're going to use these two factors, the 2 and the 4, but again, we're going to put the perfect square, the 4, first. So it's the square root of 8, and we're replacing that with the square root of 4 times the square root of 2. Alright, so we've got this here, and now what we want to do is simplify. So the square root of 4 can be simplified, of course, to 2. So since the square root of 4 is the same thing as 2, instead of us having the square root of 4 written here, we're going to write 2i. Alright, there was already an I there, but again, we're changing the square root of 4 and rewriting it as 2. So this other part, the square root of 2, that stays just how it is, because that doesn't, that doesn't simplify, or can't be simplified any further. So this is how we would have to write out our final answer. Alright, so we're going to look at two more examples here. Okay, so example 4 here. First thing we want to do, get it so that the part that's being squared is written by itself. Alright, so remember, we can see here that the part that's being squared is x plus 1. Right now we've got this 9 that's keeping it from being by itself. So let's see, if we subtract 9 on both sides, the 9s cancel out. We're left with, that negative is still there, negative x plus 1 squared equals negative 36. Alright, so remember, guys, that technically this is a negative 1 here. So I want to make a brief point here. Some of you are going to be tempted to distribute this -1 or this negative sign here. Do not distribute. I'm sorry about being so loud, but it's that important. Do not distribute. Please never ever distribute into parentheses that is raised to a power. If you have a set of parentheses and it is raised to a power, do not, under any circumstances, do not distribute any numbers into that parentheses. Okay? If that parentheses has an exponent that is raised to, do not try to distribute any numbers on the outside of it. Okay? Alright. So again, we know that we're not going to distribute. Okay, so guys, the only set of parentheses that you could distribute into is one that had a power of 1. In other words, one that was pretty much written where you didn't see an exponent. Because remember, if it has an exponent of 1, more than likely you're not going to see that exponent 1 written. Alright, so when we're talking about what to do next, so since we're not going to distribute, notice here what operation is going on between the -1 and that set of parentheses. That operation going on there is multiplication. So we need to do the inverse operation here, and what we need to do is divide. So we're going to divide both sides of the equation by -1. Divide by -1, divide by -1. Okay, the -1s cancel out, and now we've got this part that's being squared isolated and by itself on one side of the equation. X plus 2 squared equals positive 36. And now is where we can take the square root on both sides and finish solving like that, and simplify, of course, if we need to. Okay, so let's take the square root on both sides. Since we've got the part that's being squared isolated by itself. Okay. Square root of this equals the square root of that. Again, taking that square root of something that's being squared is going to cancel out that square, and we're going to be left with x plus 2 equals plus or minus the square root of 36. Square root of 36 is 6. And so the last thing that we need to do here in order to solve is subtract 2 from both sides. If we want to get x by itself, we need to subtract 2 from both sides. Before we do this, let me just say, folks, please, 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 do not just say that x is 4. That is only halfway right. Okay, please, please. Remember that this plus or minus sign indicates that there are 2 versions of this answer. One version is where you have a positive 6. The other version is where you have a negative 6. Please remember both versions. My suggestion is to write it out like this, -2 plus or minus 6. To write it out like this initially, if nothing else, just to remind you that there are 2 versions of this. One version is where you are adding 6, or one version is where you got a positive 6, and the other version is where you are subtracting 6, or where you have a minus, a negative 6. So again, there are two answers here, and we can simplify these two answers because they're both whole numbers here. One answer is where you're going to have 2 plus 6, and the other one is going to be where you got 2 minus 6. Again, that plus or minus sign. There are two versions of this answer. We've got negative 2 plus 6 and negative 2 minus 6. Plus or minus. Plus or minus. Okay. So again, one answer here. One answer is negative 2 plus 6, which gives you positive 4. And the other answer is negative 2 minus 6, which gives you negative 8. Alright, so let's look at example 5 here. First thing is we want to get the part that's being squared by itself. The part that's being squared is x minus 5 in this example. We've got a 4 that's here on the outside. We've got this minus 7 that's here on the outside. Those two parts are keeping it from, are keeping that part that's being squared from being alone, isolated by itself on one side of the equation. So we need to remove those parts. Use inverse operations to cancel them out, get them on the other side. So let's add 7 to both sides. That gives us 48. And of course those 7s cancel out on the right side. And then we've got that 48 is equal to 4 times this thing here being squared. X minus 5 squared. Okay, and remember what we said in the last one, that you do not ever, don't ever distribute into a set of parentheses that has an exponent. Alright, so we don't distribute here, but we're going to divide both sides by 4. Divide by 4. Okay, the 4's on the right side cancel out, and we wind up having 12 equals x minus 5 squared. And now is where we can take the square root on both sides and finish solving for x and simplify and write it in its simplest radical form if necessary, or if possible. Alright, so let's take the square root on both sides. X minus 5 squared, and we take the square root of 12. Square root is going to cancel out with the square. And on the right side of the equal sign, we'll be left with x minus 5. On the left side, we've got plus or minus square root of 12. one thing that I've seen students make a mistake with is when they're writing out like something like the square root of 12, they'll write this without the square root. So some students will make a mistake and write this number without the square root. You can't just take away or just not write the square root. The square root of 12 is the square root of 12. I mean literally it's the value of it is 3 point something. It is the square root of 12. You can't just write it as 12. Okay? So again, make sure that if you're not simplifying it, or if it can't be simplified, that you just leave it under the radical, that you leave it as the square root of 12. Alright, so we've got plus or minus the square root of 12. Alright, and the only thing that we need to do here to get x by itself is to add 5 to both sides of the equal sign. Add 5 to both sides of the equation. So remember, guys, when we do this, add 5 here, that this 5 is not going to be that you're not going to be able to just put the 5 and the 12 together like this is 17 somehow. Remember, you can't do that. Not unless both of these numbers are whole numbers. Okay, and 12 is definitely not a whole number, or unless both numbers are radicals with the same radicand. In other words, both of these numbers would have to have be something that both said something with the square root of 12. It would have to both have 12 up under the square root, up under the radical, 12 as the radicand, and that would be the only way you could actually combine these things. Alright, so again, we can't combine these, but we can write them separately, and we should write them separately. Remember, there's two ways to write it. You can either write the 5 in front of that, in front of this plus or minus square root of 12, or you can write the plus or minus square root of 12 and then write the plus 5 afterwards. Two ways that you can write this answer, remember. Alrighty, I do hope that this video has been helpful. This video included quite a bit of different types of equations that you could solve by using square roots. Some of the equations in this video involved imaginary numbers. Some of them were ones that could have tricked you into distributing, but again, remember that you never ever want to distribute into parentheses that are raised to a power other than 1. Alright, so again, I do hope that this video was helpful to you, that you got something out of it, and that it can help you when you are solving quadratic equations using the square root. That's it, folks.